Okay, so broadly we are classifying changes into physical changes and chemical changes. In chemical changes, what is happening is, okay, certain substances combine together to form an altogether new substance, or the substance which is having its properties totally different from the original substances. This is what is, we represent this with the help of symbols. Okay, this is what we are going to call it a chemical reaction. There are different types of chemical reactions. Okay, first is we can directly write this in the form of a sentence. We can express this in the form of an equation, which we will call it a word equation. Okay, I'll take a very simple example over here. Hydrogen plus oxygen. This is giving us water. Okay. What is the symbol of hydrogen? H is the symbol of hydrogen. What is the formula of hydrogen?
Formula like H2.
That's correct, H2. Now, what is the difference between this symbol of hydrogen and this formula of hydrogen?
Formula means like two molecules of it.
Two molecules. No. Okay, symbol, when you say, that is representing an atom of an element. When you say formula, okay, it means here the atoms have combined together. Here two atoms of hydrogen have combined together. So this is the formula of hydrogen, and this H2 which is there, this we call it a molecule. Whenever atoms combine together, we call it a molecule. Okay, so this is what we have represented over here, hydrogen plus oxygen giving you water. This is a word equation, and then now we are going to represent this with the help of a symbol or formula equation. So this is going to be the formula equation. Okay, so hydrogen is H2. What is the formula for oxygen?
O.
O is the symbol of oxygen. Again, here the formula of oxygen
O2.
is going to be O2. Now, obviously, you will be knowing the formula of water.
H2O.
Correct. This is going to be H2O. Now, this equation that we have got over here, okay, this is your formula equation. But you can see over here the number of atoms that are there on left hand side and right hand side, they are not equal. Okay, so we need to balance this equation, because we cannot create atoms, or we cannot destroy atoms. If you are going to look over here, there are two atoms of hydrogen, H2 is there are two atoms of oxygen. When you are writing the formula of water as H2O, it means it is containing two atoms of hydrogen and there is one atom of oxygen. But here there are two atoms of oxygen. So we need to balance both the sides, because one oxygen is not going to disappear on its own like that only. So in order to balance this, what we are going to do is we are going to multiply this by 2. Remember, we cannot cancel out any number like this, otherwise it will change the formula. Why we are writing that formula of water as H2O, that we will deal it in a separate different topic, why the formula is H2O and why it is not H3O or something like that. So in order to balance this equation, okay, this 2 is there, it means this 2 is multiplied with this oxygen also. So here the oxygen atoms have got balanced. Now in the process, you see how many hydrogen atoms are now over here? 2 multiplied by 2. So the number of hydrogen atoms have become 4. So here also, in order to make number of hydrogen atoms 4, we are going to multiply this by 2. This is the balanced equation. Okay, when I have not written these numbers 2 and 2, that was unbalanced equation, that was simply a formula equation. When I put these numbers, the number of atoms on left side and right side, what is there on the left side of the arrow, these substances we will call them reactants. The substances that are formed which are there on the right hand side of the arrow, we will call them products. So the number of atoms on the reactant side is equal to the number of atoms on the product side. One more thing that is remaining over here is the state symbols. State symbols, it means in which physical state, whether it is solid or liquid or gas, this reaction is taking place. Okay, suppose if the reaction is taking place at a higher temperature, then obviously at all temperatures hydrogen is in the gaseous state. So we are going to represent this it with the help of symbol G. Even oxygen also is a gas at room temperature, and if the reaction is taking place at a higher temperature, then this obviously H2O is going to be in the form of water vapor or steam. Okay. So this is what is happening in a chemical reaction. A simple equation, we have considered H2 plus O2 giving you H2O. Now all chemical reactions that are occurring, they will have a particular speed. It means some reactions are going to be very fast and some reactions are going to be very slow. Okay, we were saying that some reactions are very fast while some reactions are very slow. Can you give me some other examples of chemical reactions that you know? Any other example of chemical reaction?
Magnesium plus oxygen gives magnesium.
Okay, magnesium plus oxygen.
It's magnesium oxide.
This is giving you magnesium oxide. Okay, so this is the word equation that you have given
And
me.
at the end, will you be coming to like the oxidation and reduction part also?
Yes, we will do that oxidation reduction part also. Okay, and how we are going to, there are various definitions of oxidation reduction, then what is a redox reaction. I will be giving you several examples also to solve. Then what is an oxidizing agent, what is a reducing agent. So all these things we will be doing in the other classes. Okay, now this is the word equation. Obviously here the reactants are there on the left hand side of the arrow. So these both are the reactants. And magnesium oxide is the product. If you see burning of magnesium oxide, it burns with a bright flame. Okay, I'm just going to show you that video or picture. Alright, so this is one of the examples of chemical reactions that we have considered here. We have seen that experiment also. Magnesium is burnt with a dazzling white flame and it is producing a white powder, that is magnesium oxide. So magnesium and oxygen are reactants in this, and magnesium oxide is the product. And obviously this is a bit of a fast reaction. We can take some other examples also of the reaction which are quite slow enough. For example, I'm considering here rusting of iron. Okay, rusting of iron which is there. This is an example of a slow reaction. It's quite slow. Okay, what is formed over here is the brown flaky substance which we call it rust. There is also a formula of rust. Afterwards we are going to see also the experiments. How rusting of iron, what are the conditions for rusting of iron to take place? You are going to ask something?
No, I was just saying iron oxide.
That's correct. Okay, it is iron oxide. The formula of rust basically is going to be Fe2O3 dot XH2O. This X represents any number of water molecules are present in rust. Okay, so iron is there, oxygen is there, and presence of water. So two things are necessary for rusting of iron. One is air or oxygen should be present because air contains 20% oxygen, and moisture or water also should be present. In absence of any one of these factors,
Yeah.
rusting of iron will not take place. So that will come under methods of preventing rusting of iron because it's a wasteful process. It wastes the structures of iron or even steel. Can you give me any other example of chemical reactions?
Oh yeah.
Any chemical
Zinc.
reaction that is outside the laboratory?
Oh, not sure, but zinc oxide.
You are telling me everything that is concerned with chemicals or anything that is happening in the laboratory. Anything that is apart from laboratory that you can tell which is a chemical reaction. Yes, tell me.
Oh, outside laboratory, can you give like the chemical reaction for photosynthesis?
That's correct. That's one of the examples. The simple example that I can take is digestion of food.
Oh yeah.
Then respiration, photosynthesis. Okay, these are all the chemical reactions that are happening in the biological world. It is happening in a cell. Okay, so all these examples, this the food which you are eating. Okay, their composition is different from what the digested food is. Because inside your stomach and inside your digestive system, various chemical reactions are happening, and this food gets converted into some other new substances. So these are all examples of chemical reactions that are taking place inside a living organism. We can also represent a chemical reaction of respiration or photosynthesis. First, I'm going to consider the chemical reaction of respiration. Obviously, this is also not a very fast process. It is a slow process, but it is also not so slow also as rusting of iron, which takes quite a long time. Okay, so I'm going to write down here the chemical reaction for respiration. What is the starting substance for respiration? We have done this yesterday, day before yesterday. What
Yeah.
happens in
So you have
respiration? Pardon?
glucose plus
Correct.
oxygen
Correct. This is the word equation. Glucose plus oxygen. This is going to
gives
give me.
CO, carbon dioxide
Correct. Carbon dioxide
plus water.
plus water. Anything else?
Mm.
Plus it is energy. Correct.
Yeah,
Respiration
right.
is the process. Respiration is the process in every living cell to release energy. This energy will be released in the form of ATP molecules. Okay, afterwards we are going to do this in biology. ATP, this is adenosine triphosphate. Okay, it is known as energy currency or energy resource in any living cell. So this is the chemical reaction that we have written. This is the word equation. Now we are going to write down the formula equation for this. Okay, so this is going to be, what is the formula of glucose? We have done this. The formula of glucose is C6H12O6.
So you're frozen.
You can't see the screen?
It's 12O6
Okay.
plus
Oxygen is O2. Carbon dioxide, what is the formula of carbon dioxide?
CO2.
Correct. The formula of carbon dioxide
CO2.
is CO2.
CO2.
And water obviously will be H2O. And plus
H2O.
energy will be
And
I'm just representing it this with the help of a triangle. We are going to balance this equation. Have you done balancing of equations? From word equations to formula equations, these from balancing of equations, have you done them? Then I'll send you the worksheet if
We
you have
haven't
done them.
done balancing of equation.
You have done or you have not done?
Not done.
Okay. We will balance this equation. Okay. Here C6, it means here 6 carbon atoms are there. So I'm going to multiply this number by 6. This gives me 6 carbon atoms. How many hydrogen atoms are over here on the left hand side?
12.
Okay, 12 are there. So I'm going to multiply this also by 6. So it's going to give me 6 to 12 hydrogen.
Yeah.
Okay. Now we check for oxygen atom that is remaining. On this side we have 6 into 2, 12 oxygen atoms are there. Here 6 oxygen atoms are there. Okay, I'm supposed to put a number over here so that oxygen is getting balanced. Here on glucose side 6 oxygen are already there. I need 12 more. 12 more oxygen atoms are required. So I'm going to multiply this by 6. This is how I'm going to do balancing of equations. I'm going to send you a few links also how balancing of equations have to be done. Okay, few pre-recorded classes are there. So those classes, those links, through those links you can do this balancing of equations, and then I'm going to send you a worksheet. So this was a balanced equation for the process of respiration. This is quite a bit of a slow process. I will also give you the differences between burning and respiration. Okay, first of all, the difference that is there is that in respiration, this is taking place in a living cell. Burning can take place anywhere outside the living cell. Okay, in respiration, the starting substance is glucose, C6H12O6. That is in respiration. While in burning, it can be any other substance that can produce energy. It can be any carbon containing compound. It can be any other substance. It can be any other element. Even plastics also, when it burns, it produces energy. So that will be the process of burning. We also call combustion the process of burning. Any petrol or diesel that also is burnt.
Yeah.
This also on burning will produce carbon dioxide, water and energy. Okay. This is the difference. So fuel can be anything, petrol, diesel or any substance that can be burnt to obtain energy. So this is the next difference. One more difference is respiration. There is no flame. Okay. While whenever burning is taking place, in most of the cases, a flame will be accompanied. A flame will be produced whenever burning is going to take place. In most of the cases, this is going to happen. So these were the differences between burning and respiration. Okay. This was about chemical reactions that are there. We have done what are the starting substances. We call them reactants. These substances on chemical reaction occurring, they get converted into products. Okay. Now the next part that we are coming, the next definition that we are coming is what is a rate of a reaction. Okay, rate of a reaction, basically it means speed of reaction. Now whenever chemical reaction is taking place, the reactants are becoming products. Okay, so when this chemical reaction is happening, the amount of reactants, the quantity of reactants that is there, that will keep on getting reduced. It will keep on decreasing. While the amount of products, the number of particles, the number of molecules of products which is there, it will keep on increasing. This amount, we can call it, the term that we can use it over here is concentration. So whenever a chemical reaction is happening, what is going to happen to the concentration of the reactants? It will decrease. The number of particles of reactants will decrease. Okay, I'll take one simple example. Another example I'm taking over here. Say for example, if I'm having H2, hydrogen, chlorine, this is chlorine gas. Okay, this is forming HCl, hydrogen chloride or hydrochloric acid. Obviously, the balancing of this equation is simple. Can you suggest me the balancing?
Yeah, so 2 HCl.
That's correct. It's going to give me 2 HCl. So this is a balanced equation. Now, before the chemical reaction has started, there will be a fixed number of hydrogen molecules. There will be a fixed number of chlorine molecules. When you mix them and subject them to certain condition, the chemical reaction will start occurring, and this hydrogen and chlorine will start getting converted into hydrogen chloride or hydrochloric acid. Okay. Of course, we'll see the difference later between what is the difference between hydrogen chloride gas and hydrochloric acid. That part we are going to see later. Now here, as the chemical reaction is happening, the number of molecules of hydrogen, the number of molecules of chlorine, this will keep on decreasing. And obviously the number of molecules of HCl will keep on increasing. Now, how fast this is going to happen? That is going to give us the rate of a reaction or rate of a chemical reaction. So we can define rate of chemical reaction like this. Okay, it is the change in concentration of the reactants or change in concentration of products with respect to time that you can add, or you can simply say it is the increase in concentration of products or decrease in concentration of reactants. Okay, so this is going to be the definition of rate of reaction. I will make you write the definition of rate of a reaction, and then we are going to see what are the different factors that are going to affect the rate of reaction.
Yeah.
Okay, so we'll note down this definition, you will copy it down, and then we'll come to the factors of rates of factors affecting the rate of reaction.
Yeah.
Okay, so this is the definition of rate of reaction. Is defined as the rate of change of concentration of reactants or products. As the reaction proceeds, concentration of reactants decreases and the concentration of products increases. The substances taking part in the reaction are called reactants, and the newly formed substances are called products. You can take down these definitions, and then we are going to go into factors affecting rate of reaction.